Hey folks, can everyone hear me? I'm going to use the mic throughout this experience so we can make sure the folks in the back can hear. Glad everyone was able to make it despite some scares from the snow. Bostonians, you got to teach your cabbies how to drive faster. We're much better in New York at this stuff. Okay, so today we're going to talk about microservices. I had a sneaking suspicion when I put this talk title up it was going to win because it's such a hot buzzword right now. So hopefully the content lives up to the expectation. So the short intro to this thing was saying how a service-oriented architecture, it looks really good when you draw this on a whiteboard. There's boxes and lines, and you feel really good about architecting the system. But how does it work in practice? There's a lot of benefits of flexibility, but then you have a lot of overhead with administration. You have to track more metrics. All sorts of different things can fail in interesting ways. So at Tapad, we're a Scala shop. We built a framework on top of Finagle, and that enables a pretty simple approach to building and deploying microservices. Oops. Oh, I'm Toby. I already got past that part. Okay, so sort of at a high level, the left side here we have the concept of a monolithic application. Gray box is a server. Colored boxes are various internal services. On the other side, we have the microservice approach where there's essentially one container per service. So our initial application started out as a monolithic service. This is much easier to do, but at some point, you're going to hit a scaling problem where it doesn't make sense to create new instances of the same application because all the internal services have very different traffic patterns, different scaling idiosyncrasies, and so on. So if you were to use the monolithic approach, and let's say you want to scale up the red service, you basically make a clone of your same application, use memory for all three services, and in this other approach on the side, you just have to spin up the one. So that's one of the nice advantages. But what is a microservice to begin with? It's a buzzword. Is it different than a service-oriented architecture? I don't know. Is this a microservice? Okay. No, it's a nanoservice. Okay, well, what if we just change the type to return a future? Does that make it a microservice or a service? No, is also the answer to that. But you are doing RPC, so you want to deal with getting futures back, so you have a little bit more flexibility. And then at some point, you're going to wait for results, but you want to deal with futures kind of all the way. But okay, so functions are not microservices, and functions that return futures are also not microservices. There's lots of definitions out there. This is one that I think works pretty well. Just a logically grouped set of functionality, and it's deployed independently. So the independent deployment is really the important part here because a logically grouped set of functionality is just good software engineering in general. It doesn't need a special word. Just code smart. Think about what the organization matters. So lines of code don't really matter. That's what I was trying to get at with the nano-service examples. Amazon has a definition of microservices, which is the two pizza concept. So if you can have two pizzas that will feed the team that works on one service, and that counts as your microservice. That's not a bad description, I guess, but I think in practice, the number of developers really doesn't matter at all. It's just about grouping a functionality and being able to scale up that application independent of everything else. So if that's the case, why do we have different names for this? All of a sudden, we're talking about microservice instead of SOA, so service-oriented architecture. I'm pretty sure the reason is that service-oriented architecture just started getting a bad name when they became the clunky monoliths that they were meant to replace. So microservice is a rebranding of the same concept. It's still a good one if you do it well. Just sort of a tautology, but it's also the truth. Okay. Should you use them? No, unless you need to. It's much easier to work on a monolithic app to start. I mean, why deploy 3 things or 10 things when you can deploy 1? However, like I mentioned before, you will hopefully, if your company hits a good scaling problem, everything goes up and to the right, and things start failing. So Tapad hit this point a few years ago where we had a monolithic application doing everything, and we realized at some point there were 7 different applications in one project, basically. Not even services really, just actual different applications. So we started this process by breaking the project up and having an independent, so an event tracking server on one side, a bidding server on the other side. So Tapad's an ad tech company. We do real-time bidding. So that's what the bidding part is. Essentially, you get an HTTP request, do a little bit of processing, send a response back. Not important for the talk, but so after we broke up this monolithic application, there's no RPC between them, because remember, they're different apps. They really just communicate via state change in a database somewhere. We take a request, put it onto a data pipeline, something else pulls it off later, makes a change to the database. Now your next application can do a read, and that's all that you need. But now we're in yet another different phase of our architecture evolution, and we need these microservices. The big distinction is that they're some kind of shared service. You don't want to copy the functionality around. Copy and pasting code is terrible. But also, you don't want to deploy the same code in process sometimes because you want to be able to scale differently. So now we use RPC on top of Finagle. So when should you use microservices? These are 2 hints. If you have some code smells in your application, for example, you have multiple different boots. So you have, put a feature flag in there and you start up one application as the bidding server, and you start up the same application but with a flag that says this is an event tracking server. That's a code smell. Maybe you need to separate those things into different applications or maybe different services if it's some kind of shared functionality. Okay, so if your deploys start getting really unwieldy, this is another time you might want to consider switching into microservice architecture. The classic example here would be you have a slightly larger team. They're each branching the code base, adding some different features. The features are totally independent, but they're deploying the same application. And this means that you have to coordinate 2 independent features just to get a deploy going. And then if one of them breaks, maybe you need to do a rollback that's awkwardly coordinated with the other feature that wasn't breaking, and it gets a little bit hairy. You can solve this with feature flags as well. So for example, you just have a shared state setting. We use Zookeeper. You switch this thing to on or off, use version A or B of the software. But it's impractical to put everything behind feature flags. You end up just having large code blocks that say, if feature A is on, do all this. It's a little bit wacky. So if you separate everything into a microservice, then you can do independent deploys, and it'll be much simpler. Okay, so the advantages, as I've alluded to here, you scale different parts differently. It's not magical, but if your application gets big, you're going to have a traffic pattern that is sort of wildly different. One real-world example from Tapad is that we have this very large binary data file, and one of the applications needs to parse this thing on boot, store it off heap, have some pointers there for doing various quick lookups. But this is not the fastest process. It just takes a couple of minutes. That's not bad. But if you change an independent part of that application and you redeploy, and even with the automated one-click deploy process, you have to wait maybe an extra 30 minutes for the whole thing to roll because there's a lot of nodes in this cluster. So by separating that particular part out, you just have a service that wraps that data file, and when you make a separate change, you don't have to do the slow boot again. So another advantage is just organization of your development team. It's simpler, in my opinion, to have just 1 or 2 maintainers on a service who are the ones who are kind of the authoritative pull request reviewers, and they don't need to clobber somebody else's code base. Of course, you can do this in a monolithic application as well if you have things nicely organized into good class files and so on, the appropriate packages. But I think in practice, it's easier to do that when you have an entirely separate code base. Okay, so what about disadvantages? This is obviously not a panacea. So there's more to keep track of. If you have one application that has, let's say, 100 metrics that you want to keep around in Graphite, and then you have 10 services, now you're going to have 10 times 100 metrics to keep track of and processes that you want to keep running. RPC is slower than an in-process function call. This is pretty obvious, but maybe not so obvious when you're drawing things on the whiteboard. So keep that in mind. Also, you have to choose a protocol to communicate between the client and the server. You can't just use a plain old Scala object. Well, I guess you could. But if you're also using different code bases. So let's say you have a Node.js service that returns some JSON, and then you have a Scala service somewhere else. You need to pick something to communicate. That wire protocol is your interface that you need to track the version of and make sure that you are backwards compatible when you are rolling clients and servers forwards and backwards. That sounds kind of hairy, but in practice it hasn't been that much of a pain. You just have to be sort of conscientious about keeping deprecated fields around just long enough that all your clients are upgraded, then remove them. This is really easy to do using Finagle, actually, because you just set a version of your protocol. Server, when it comes up, will register that with its host and port in Zookeeper. And so the client will say, hey, I'm looking for the foo service version 3. OK, here's a couple servers I can connect to, no problem. You can also have an old version 2 sitting there running totally independently. And then once things stop connecting to the version 2 server, you're good to go, and you can kill it. So even though you have a wire protocol, you can have the compiler help you know when your client and server are going to be out of sync. In a moment, we're going to get to some more code. In fact, there. So you are going to have the compiler tell you these things will break if you change the protocol. That can be a sort of tricky thing if you have a stringly typed interface, for example. But if you use thrift or something like that, the compiler will help out. OK, so this is the way that Tapad makes services now. We use SPT for all of our plugins. And we have an SPT plugin here called servicebuild. Simply extends an SPT project. And you set up a root, client, embedded, and server. And we'll get into a couple examples of these later. But essentially, this makes it very simple to start a new project because you just include the plugin. You give your service a name. You automatically have some projects set up here. And you can see a certain number of dependencies here, which are pretty interesting. So we decided that we'll put the domain objects and the protocol into the client. The client is very lightweight. The server is pretty lightweight. And the embedded project is where all the domain logic happens. So actually, as I was writing this presentation, I noticed that our project setup looks really similar to the Remotely project that some folks, Runar, Paul, some other folks around here have made a similar thing. So I guess we're onto something. OK, so here we have the client service definition in Thrift. So there's a domain object called greeting. It's a very simple example. But you also define a service that takes this thing. And it will eventually generate some Java code, or sorry, some Scala code that gives you the RPC server. The client also contains that version number that I mentioned before. And since the server depends on the client project, that's how they're able to communicate via Zookeeper, so you connect to the correct version of the service that you care about. OK, so there's also client bootstrap code. This is not in the SBT plugin. It's just some extra bootstrap code, which shows you how simple it is to make a new client here, pick an execution context, and you call bootstrap, and this will just start up a client. And then you have your methods on here. So client.greet, which takes an option of a string. You can see looks awfully similar to our service over here, where you have greeting and then optional string name, the same types. OK, so here we have an example of an embedded project. This is where all the domain logic goes, all the heavy lifting of the application. So the way that this is supposed to work is you write all your code in the embedded project. You have the server project that depends upon the embedded project, so it gets the implementation. When the server starts up, it basically just does a translation between some internal domain, so plain old Scala objects, basically, and then whatever the wire protocol is. We have a couple instances where the embedded project is instantiated inside of some process. This, of course, throws away all the benefits of the independent deployment, but all good engineering requires trade-offs, And sometimes you need the speed of just having an in-process function call versus RPC. Okay, so here's an example of the server project. And so you can see that it, actually, is this visible to the folks in the back? It looks great on my laptop screen. Okay, sounds like a yes. Okay, so again, the point is that I want to emphasize here is that this is very, very simple. You have a server bootstrap, which is the server equivalent of client bootstrap. You just give it a type, it fires things up, connects to Zookeeper, announces its presence, and then just sits there and waits for someone to connect. So the next slide is going to start going into some of the operational concerns. But I did want to go back to some of the disadvantages, or rather things to consider when you're making a service-oriented architecture. There's no magic about it. So if, for example, you have a service that is in front of a database and just does some kind of database call, your database is that's the bottleneck of your application. You cannot simply spin up more service instances and get better performance. This is not always super obvious if you're not thinking about it, if you're just writing your application code, because one of the boons of Finagle is that you can actually just spin up a service and you will automatically get load balancing, but you cannot avoid the fact that sometimes there is some shared state or some shared service behind the scenes. So you always have to keep that in mind and basically just track lots of metrics and see when things start failing. Okay, so for operations, we basically brought in a bunch of other plugins into the servicebuild plugin that helps us keep track of all these different things. When you have one monolithic application, you sort of really just need one version number, or just keep track of master or a production branch. You don't even need to worry about versions. Once you start actually separating things out, this is true of libraries as well as services, you need to track those versions. So how many people here use SPT release? Not as many as I thought, so less than half. But it's a great little plugin. Basically just wraps a couple common things that you want to do. You run SPT release, it checks that your build is clean, runs tests, bumps the version, tags the repo, pushes all that back to your upstream. And then we have a build server that will figure out, we've got this new release in place, what should we do about it? So let's run SPT Assembly. It's another plugin that takes all your files, puts them into one fat jar. It's a little bit more easy to deploy. And bless you. And so this is an example of our build file. This is how you make SPT Assembly do its magic. The top is just the main class, then the name of the jar, nothing too special here. One of the cool things about SPT Assembly, and the reason we use it as opposed to something like SPT Pack, or like the standard like SPT Native Packager dist function or stage, is that you have control over how you handle merge conflicts. So here's a very simple example. If you've got a bunch of these different files, just discard them. You can also concatenate or pick first, last, something like that. Okay, so speaking of SPT Native Packager, this is a newer one in the Tapad ecosystem at least. It will take your application, package it up in any number of different formats. The one that we use is RPM because we're on CentOS and we've got an ops team that likes using all the established tools. So system5 init scripts are generated for you automatically. You say sudo service, foo start, stop, status, all those things are very robust and tried and true. That said, SPT Native Packager is a little bit complicated to set up. There are many, many, many different things to configure, and I found myself reading the code more often than reading the documentation to figure it out. But now things are kind of tidy, and it works very nicely. One thing I wanted to call out here is just an example of how you would take some settings here from SPT Assembly and just merge them right into the Native Packager setting, so you don't need to duplicate this code and configuration all over the place. So SPT Native Packager and SPT Assembly are not designed to work together natively, so that's why here we have a couple overrides basically. you say that there's just this one jar instead of a list of jars. And the mappings and universal part here basically says, disregard every single jar that you think you want to put into this package, except for the one that I tell you, which is the fat jar. Okay, so this is another one that's more on the ops side of things. We use Puppet to maintain configuration, and we don't want the RPM file to take its own configuration and then obliterate the file that Puppet put in place. So to get around that, we had to figure out how to basically tweak the RPM file. Normally you would use RPM, or RPM build rather, to run your build tool like SPT and then package. So you have to jump through a few hoops with SPT Native Packager in order to tweak that RPM script to do what you want. So what this does basically is says, hey Native Packager, when you make this RPM, take these sample properties files, record that they're going to go in these locations, but do not overwrite them. Just give them this user and group, and no replace means when you do upgrade, downgrade, whatever, it does not clobber the file that Puppet was controlling. Okay, so another plugin, SBT Build Info. This one is great. It's super easy to use. I highly recommend everyone do it. So this will just generate some source for you, and on some of our projects now, we have like an internal admin module, and you can curl an endpoint, and it will report back to you what is the name of this project. This is from your SBT configuration, the version, Scala version, SBT version, which is kind of nice to know. And then you can also put in whatever else you want. So these examples show the build time. That one is just from the README. It's kind of fun. It shows how long it took to compile your application. The build host is useful because we normally want the CI server to actually do all the building, but if you want to rush out a hotfix or something like that and you build on your laptop, maybe there's something wacky in your environment that's different, you want to know about it, the build host will record this. And then the git SHA essentially does the same thing, so you know exactly what version of your build is running. It makes this process very repeatable. Okay, so just a couple other points that didn't really fit into the other high levels here. Since we're using Finagle by Twitter, we also will use Twitter server's admin module to introspect the application. Basically, there's a few endpoints. Again, you can sort of curl them. They will profile the application, take samples of running threads, and you can kind of see what's maybe getting locked or taking up too much time, and you can optimize that. Metrics. Oh. Metrics are really important. We use Graphite. You'll get a lot of them basically for free, so the general JMX stuff you'll get for the JVM. Finagle also tracks what sort of clients are connecting to it, what methods they're calling. And also load balancing. So there's essentially two ways to handle load balancing. You either have a kind of smart client that deals with things, or you connect to a load balancer, which then knows about the services behind it and routes them. There's no need for that extra hop. We have load balancers on the edge of our services, but inside we use Finagle to handle that. It's a smart client. Like I mentioned before, it just connects to Zookeeper and figures out what hosts are there. And it will connect and do the load balancing on its own. So what's next for the Tapad SPT build plugin? Some of the things that I showed you are not in the plugin yet. They're sort of independent on various applications as we're figuring out how to make them work. So we're going to consolidate all that stuff and potentially make an activator template so it's even easier to start up a project like this. And that's all I have. There are a few minutes available for questions if anyone has any.